Hi there. I am Corey Birchman. I am a physician. I'm an anesthesiologist by training as well as a pain management doc, and my subspecialty is neuroanesthesia. My specific interest is in neuropharmacology and how drugs interact with the body and especially the brain. I have been in the cannabis space and I've been employing it in my pain management practice as well as studying its therapeutic and pharmacologic effects for over 30 years. I put together this slide presentation for you because cannabis has become much more mainstream as both a therapeutic and recreational product. Marijuana is becoming something of a staple once again in the American healthcare setting. I think there's still a huge void in educating physicians and healthcare providers with evidence-based therapeutic guidance regarding medical marijuana. There are many, many molecules in marijuana that have healing and drug-like abilities. The class of drugs are called cannabinoids, named after cannabis itself. You've probably heard of THC, also known as delta-9 THC or tetrahydrocannabinol, and CBD, known as cannabidiol. These are two of the prominent cannabinoids that we find in marijuana. There are other compounds, essential plant oils called terpenes, and I will discuss some of the exciting things terpenes might do for the body in another segment. But today, for this presentation, I just want to talk a little bit about the science and background of cannabis. I'm going to talk about the drug-like behavior of some of the cannabinoids and how they might be used in treating disease and providing wellness. And then later, I'll discuss the many forms of cannabis that you can take. As of April 2024, recreational marijuana is legal in 24 states, or nearly half the country, and medical marijuana is legal in 37 states, according to the Pew Research Center. There's a lot of variation in medical cannabis laws from state to state, including how it's produced and distributed, and how it can be consumed, and what medical conditions for which it can be used. Many physicians still remain uncomfortable qualifying patients for medical marijuana due to what they perceive of as a lack of evidence in medical literature and a lack of education surrounding the subject. I get the sense that many healthcare providers feel that a good basic understanding of cannabis and medical marijuana just isn't really digestible. I have continued to push for educational modules just like this one, but geared towards physicians and healthcare workers. I think that the knowledge supporting cannabis for disease management and therapeutic use is extremely relevant. We have a huge population of Americans, literally millions of our patients, presenting with chronic conditions that are medicating with marijuana, self-medicating, particularly when conventional therapies have failed them. And with that, the purpose of this presentation is to dispel some of the misunderstandings. I want you to think of this as a cannabis power bar, a cannabis knowledge power bar. It's something small, easily and quickly digested, and purposeful. To understand why cannabis works in the body, you have to have an understanding of something that's known as the endocannabinoid system. The ECS, or endocannabinoid system, is an expansive network of nerves and something called receptors. Receptors are special areas on nerve cells as well as other cells that attract and hold specific molecules, in this case THC. This is the basis for how drugs actually work. Drugs are swimming in the bloodstream. How they get there is another story, but drugs in the bloodstream glom on to a receptor after being distributed around the body. It's sort of like a lock and a key, where molecules like THC represent a unique key that only opens the lock on the receptor, which is on top of a cell. And once that key goes into this lock, it unlocks all sorts of things. And this is a big medical word called neuromodulation. But it really doesn't matter what you call it. What's happening, though, is kind of important and kind of special. Unlocking the key to the receptor, in this case a cannabinoid receptor, plays an important role in all sorts of things in the body, particularly in the development of the brain and the spinal cord. It turns out that this body produces special molecules that look a lot like THC and other cannabinoids found in the plant. These are called endogenous cannabinoids. Endogenous means created from within. Scientists have uncovered this very extensive network of these receptors in the brain and throughout the body. And the thing is that these receptors have in common a very important aspect. They serve as locks to the key of marijuana-like particles that the body produces. Now you might ask yourself, what is this endocannabinoid system all about? Why does it exist? And why the hell does the marijuana plant produce molecules that can activate these receptors? I am going to try and answer some of these questions. Another question I want to ask is, how did marijuana evolve as a medicine? I want to take the opportunity and take a little trip with you guys. And I'm going to tell a tale really as old as time itself. People have been looking for and using mind-altering substances since prehistoric times, really as long as humans have been on this earth. The earliest alcoholic beverages date back to about 7000 BC. Coca leaves have been found in human dental remains that are over 8,000 years old. And let's not forget the poppy plant, which gives us morphine. Traces of opioids have been appearing in human bones dating back over 6,000 years. Cannabis is fascinating. It can be selectively bred to produce strains that have a significant amount of THC or no THC at all. THC, as I mentioned, the molecule in cannabis that makes you high, that is, it has a psychogenic effect. Cannabis and hemp are the same plant, Cannabis sativa, although hemp is generally regarded as a low THC form of cannabis. The non-psychoactive varieties of hemp, where fiber is prized and is quite valuable, is grown for many industrial uses. It can be made into rope, textiles, paper, food from seeds, oil, and other products. In fact, hemp was probably the first cultivated agricultural crop, and it's been found in pottery dating back 10,000 years. The recorded use of cannabis as a drug was from about 3000 BC in China, where they used it primarily for the treatment of seizures. It was also used in religious ceremonies. Cannabis at that time was revered. It was seen as a gift from the gods. It was used to relieve pain, as well as GI disorders, lack of appetite, and insomnia, much like many people use it today. Cannabis was introduced to the West by an Irish physician named William O'Shaughnessy in the late 1800s. And he actually conducted really cool, well-designed clinical studies that were published in the medical journals of the day. And by the mid-19th century, cannabis was included in hundreds, if not thousands, of medicines, including tinctures, powders, and syrups. They were promoted as cures for diseases ranging from gout and arthritis to migraine headache and coughing. By the turn of the 20th century, only one compound had been extracted from cannabis, and this was called cannabinol, which is a non-psychoactive byproduct of THC. And in the early 1940s, the hunt was on to look for other components of marijuana, and CBD, cannabidiol, and THC, tetrahydrocannabinol, were discovered. 20 years later, the chemistry and the structure of THC was finally described in an Israeli physician's laboratory by a gentleman named Raphael Mechoulam in 1965. He was able to synthesize both THC and CBD, and that opened the chemistry door. And since the 60s, over 100 cannabinoids have been identified. This endocannabinoid system to which I'm referring plays a really vital role in maintaining the equilibrium of the body. We call this homeostasis. It really just means that the ECS is a super important system to keep the body in the most functional and prepared state it can be. It plays an important role in so many body systems: gastrointestinal function, appetite regulation, metabolic function. By that I mean the conversion of the energy in food to energy available to run cellular processes. I mean, how important is that, right? It plays a role in pain modulation, memory imprinting, movement, immunity, inflammation, and a whole lot more. The star of the show in this system are the receptors that these endocannabinoid system receptors exist. And this is known as CB1 and CB2 cannabinoid receptors. CB1 receptors are mainly found in the brain, the GI system, in certain cells of fat, liver tissue, and muscle. And in contrast, CB2 receptors are primarily found on immune cells located throughout the immune system in the body. Organs like tonsils, the thymus, the spleen, the bone marrow, as well as the nervous system of the gut. So why are there marijuana-like receptors in the body in the first place? As I mentioned briefly, it turns out that the body manufactures marijuana-like particles. These molecules are called endocannabinoids. The cannabinoids that the cannabis plant produces are called phytocannabinoids, meaning they're a molecule derived from plants. Research in the 60s and the early 70s led to the discovery of the mind-numbing effects of THC, called the psychogenic effects. This CB1 receptor is a big deal, and it turns out that it's one of the most common receptors in the brain. CB1 has been studied a lot. That makes sense since it's so common. And scientists are grappling and trying to understand why we have so many of these receptors in the body. The body does not evolve mechanisms for no good reason. So just the evidence of how pervasive the cannabinoid receptors are further provides evidence that the endocannabinoids play a huge role in wellness. And because the phytocannabinoids like THC, CBD, and others can also play a huge role in wellness. As mentioned, the endocannabinoid system plays a role in both health maintenance, but as well it plays a role in disease. It's implicated in Alzheimer's disease, multiple sclerosis, Parkinson's disease, Huntington's disease, and seizure disorder. This is a bit of a complicated slide, but I really just put it up there to demonstrate the location and functions of the CB1 receptor, primarily in the central nervous system, that is the brain and the spinal cord, although there are receptors outside of that in the peripheral nervous system and the immunologic system as well. The CB2 receptor is really interesting. It's super complex, maybe even greater than that of CB1, because it's really found throughout the body. CB2, for example, has no psychoactive effects when a molecule binds to the receptor, but research studies have shown that CB2 receptors may be useful in therapies that treat a range of painful conditions, including acute pain, chronic inflammatory pain, neuropathic pain. They may be helpful in treating diseases that have an inflammatory component, such as multiple sclerosis, ALS, Huntington's disease. And drugs that turn on CB2 have been proposed to be useful in any inflammatory disorder, including heart disease, inflammatory bowel disease, liver and kidney disease. In animal studies involving cancer, CB2 drugs might reduce the metastatic spread of cancer cells and actually kill cancer cells. Again, this is in very early stages of research, but it's quite promising. If you get anything out of today's talk, I want it to be this. This is like where the rubber meets the road. The medicinal properties of cannabis can be linked to the presence of the phytocannabinoids in the plant. For reasons that nobody understands, the marijuana plant is a cannabinoid factory. The human cannabinoids have very complex molecular names, and while they don't entirely resemble the phytocannabinoids or the plant-derived cannabinoids, that is, for example, THC and CBD, the most common ones, although there are many others, the molecules in the plant turn on the cannabinoid receptors in our body. Delta 9 tetrahydrocannabinol, that is delta 9 THC, and CBD, cannabidiol, are the most biologically active phytocannabinoids. That is, they are the most active members of the molecules that the cannabis plant produces. The marijuana plant actually produces over 100 of these substances, but THC and CBD are expressed in the greatest quantity, and they are capable of mimicking human endocannabinoids. This is why cannabis is medicine. Let's tackle THC and learn a little bit about it. First of all, THC, like the cannabinoid molecules that the body actually produces, activates both CB1 and CB2. Without getting bogged down in the weeds, yeah, that's a bad pun, I know, but THC activates and stimulates these receptors in our body. So why is this important? Well, this is why medical marijuana is medical. This is where the therapeutic part comes in. THC shares the ability that the endogenous cannabinoids, that is the cannabinoids in our body, to sit on the CB1 and CB2 receptor. And through that neurologic action, it inhibits the ongoing release of other human brain chemicals called neurotransmitters, which then affects certain very specific body conditions. We call this physiologic properties. That's just a fancy term for the fact that the molecules, or as I like to refer to them, the medicines, affect conditions and processes of the body. Now, some of these processes are super important. It's that simple. Okay, let's now look at CBD, cannabidiol, which I think incidentally is a more interesting molecule than THC. CBD is non-psychoactive, which means it does not create the high that THC does. The structure and drug effects of CBD, that is its pharmacology, was first described way back in the 1960s. It's very interesting because initially it was thought to act at the cannabinoid receptor like THC, but really it only binds to CB1 and CB2 at very low levels. But it's important. The medical uses for CBD are extremely broad. It's been shown to have anti-anxiety, anti-psychotic, brain protection properties. Researchers have looked at CBD in treating other health conditions such as substance abuse and dependence, seizure disorder, schizophrenia, social phobias, PTSD, depression, bipolar disorder, insomnia, and even movement disorders such as Parkinson's disease. By now, I hope you're gaining at least a bit of appreciation for the fact that the marijuana plant, Cannabis sativa, is actually a little green factory churning out these cannabinoid compounds that act as drugs in the body because they act pharmacologically, and they mimic or mirror actions of compounds that our own bodies produce. And while I've only lightly touched on this, I think it's important to know and appreciate that the two most common compounds in cannabis, THC and CBD, often work in tandem. It turns out that CBD has a moderating influence on some of the major THC effects. For example, CBD can alter the pathway by which THC is broken down by the liver. The THC-CBD ratio may result in more prominent psychoactive effects, while a lower THC-CBD ratio may limit some of that psychoactivity. There's so much more to this endocannabinoid system, and we're really just scratching the surface. You know, the initial discovery and subsequent extensive research over the last 30 years of this ECS ranks it as one of the most important discoveries in body systems and disease management. The cannabinoid receptors have gained tremendous interest as well as respect over these years, and they not only support the promise of potential as a drug target, but I think it validates the medical effectiveness that millions of people over thousands of years have demonstrated that forms of cannabis are medically effective. The FDA and the DEA finally, just this past month I think, agreed that this year, 2024, because of the low abuse potential and the medical usefulness of marijuana in certain diseases, they're going to reschedule cannabis from Schedule 1, which means it has no valid medical utility, to Schedule 3, which means it has bona fide medical therapeutic usefulness. Now, in subsequent presentations, I'm going to dive more deeply into the formulations and strains of cannabis, and we'll look at some of the routes of absorption and administration for their patients, as well as some of the pharmacokinetic data, which means once you ingest marijuana, how does it get to the receptors? And I think this is going to help serve the physician as well as the healthcare provider to give a better level of care to their patient and help them make informed choices in treating some of their medical problems. And finally, in another presentation, I'll talk specifically about the therapeutic options, what diseases are amenable to this type of therapy, and where the data lies, and actually where the data doesn't lie in the use of medical cannabis. Thanks so much for listening.